Basic Programming.
Good day everyone! Again, I am Teacher Jo and welcome to our computer class. Our topic for this session is non-procedural programming languages. These are Visual Basic, C++, Java, and Delphi. At the end of the topic, you will define non-procedural programming languages. Identify the concept of object-oriented programming languages.
Objectives. 1. Define non-procedural programming languages. 2. Identify the concept of object-oriented programming languages. Topic 4. Non-procedural programming languages. 4.1 Visual Basic. 4.2 C++. 4.3 Java. 4.4 Delphi.
The Object-Oriented Programming. Object-Oriented Programming, or OOP, is a widely used concept in programming, and almost all the modern languages except C language follows OOP principle. It is a programming style that is associated with the concept of class, objects, and various other concepts revolving around these two, like inheritance, polymorphism, abstraction, encapsulation, etc. If you're starting with C++ or Java or Python, you will soon be introduced to classes, and in no time the word object will start following you like shadow. So before OOP starts to haunt you, it's better to know OOP so that when you first see its implementation, you embrace it with a smile. The objective of this video is to discuss and understand the concept of class, objects, inheritance, abstraction, encapsulation, and polymorphism. Let us try to understand a little about all these through a simple example. Human beings are living forms broadly categorized into two types, male and female, right? It's true. Every human being, male or female, have two legs, two hands, two eyes, one nose, one heart, etc. There are body parts that are common for male and female, but then there are some specific body parts present in a male which are not present in a female, and some body parts present in female but not in males. Not getting into specifics here, but we know that a male and a female are different physically. Also, all human beings walk, eat, see, talk, hear, etc. Now again, both male and female perform some common functions, but there are some specifics to both, which is generally not valid for the other. For example, a female can give birth, while a male cannot. So this is only for the female. Human anatomy is interesting, isn't it? But let's see how all this is related to OOPs. Now, I will try to explain all the OOPs concept using this example, and later we will have the technical definition for all these. First is class. Here in our example, we can take human being as a class. When gods would have decided to design humans, they must have had some basic set of features in their mind initially, and then later on the concept of male and female would have hit them. Let's not get too mythical here. So basically a class is a blueprint with core features and functions set, like human being having body parts like legs and hands, etc., and performing actions like walking, breathing, eating, etc. Next is inheritance. Considering human being a class which has properties like hands, legs, eyes, etc., and functions like walk, talk, eat, see, etc., male and female are also classes, but most of the properties and functions are included already in the human being class. Hence, they can inherit everything from the class human being using the concept of inheritance. So when we say a male and a female both inherit the class human being, we mean that as they have some common features which we have already implemented in the human being class, hence we do not have to implement them again in the male and female classes. They can simply inherit them from the class human being. So that is the concept of inheritance. Next is object. My name is Abhishek and I am an instance of class male, because I'm a male, obviously. When we say human being, male or female, we just mean a kind. You, your friend, me, we are the forms of these classes. We have a physical existence, while a class is just a logical definition. We are the objects. So male is a class of which I am an object with the name Abhishek. Next is the concept of abstraction. Abstraction means showcasing only the required things to the outside world while hiding the details. Continuing our example, human beings can talk, walk, hear, eat, but the details are hidden from the outside world. We can take our skin as the abstraction factor in our case, hiding the inside mechanism from the outside world. Then we have encapsulation. So the concept of encapsulation is a little tricky to explain with our example, but I will try. Our hands help us to hold things. Our legs are bound to help us walk. This binding of properties to functions is called encapsulation. Last but not least, polymorphism. So polymorphism is a concept which allows us to redefine the way something works by either changing how it is done or by changing the parts using which it is done. Both the ways have different terms for them. One is called overriding and the other one is called overloading. So let's see what overloading and overriding means. So if we walk using our hands, for example, we start walking using our hands and not our legs. Here we will change the part used to perform something, hence this is overloading. So when we have a function which has, for example, one argument and the function is operating on that argument, and now for the same function we start taking a different argument. So this is called overloading, where the arguments are changed, the number of argument or the type of the argument changes. Whereas overriding is a little bit different from this. If the defined way of walking, for example, everyone walks in the direction of their face, what if someone asks you to walk and you start walking backwards? So now you're walking, but you're walking differently. So this is overriding. When you change the mechanism of function, it is called overriding.
Non-procedural languages. These programming languages are considered as object-oriented programming languages. They are event-driven, which means that a programmer selects an event that needs to occur before the instruction or statement is executed. It is different from a procedural language, since statements as a whole when an executed line per line. Instead, a series of instructions are executed as a whole when an event occurs. Examples of events are click, double-click, drag and drop, mouse over. Object-oriented is a programming style which is associated with the concept of class and object and various concepts like inheritance, polymorphism, abstraction, encapsulation, etc. Here are the definition and examples. 1. Class. It is the design or blueprint of any entity, which defines the core properties or functions. Example: class, human being. 2. Inheritance. OP. The meaning of inheritance is very close to its actual meaning in English. Example: human being class, inherit, male class, and female class. 3. Object. An object is an instance of a class which has physical existence. Example: my name is Marcus, and I am an object of class male, Marcus. Object type male. 4. Abstraction. Abstraction means hiding details from the outside world. Example: human being class. Hidden details. Outside world. And it can be happened to some other class. 5. Encapsulation. Encapsulation refers to binding properties with functions. Example: human being class. Body parts are hands, feet, eyes. These body parts have their own functions. Hold for hands. Walk for feet. See for eyes. The binding of properties with functions in a class is known as encapsulation. 6. Polymorphism. Polymorphism means many forms. The cause of polymorphism is overriding and overloading. Examples of object-oriented programming language. Visual Basic is a third-generation event-driven programming language from Microsoft, known for its component object model COM programming model, first released in 1991 and declared legacy during 2008. Microsoft intended Visual Basic to be relatively easy to learn and use. In 2002, Microsoft released Visual Basic.NET VB.NET to replace Visual Basic 6. Thereafter, Microsoft declared VB6 the legacy programming language in 2008. Fortunately, Microsoft still provides some form of support for VB6. VB.NET is a fully object-oriented programming language implemented in the .NET framework. It was created to cater for the development of the web as well as mobile applications. However, many developers still favor Visual Basic 6.0 over its successor Visual Basic.NET. C++ is an object-oriented computer language created by notable computer scientist B. Hornstrauss as part of the evolution of the C family of languages. Some call C++ C with classes because it introduces object-oriented programming principles, including the use of defined classes, to the C programming language framework. C++ is pronounced C++.
Okay, so what I have here on the left side of the screen is a basic text editor. What I have here on the right side of the screen is a terminal. Everything's going to be exactly the same as long as you use G++ to compile your programs, no matter if you're on Mac, Windows, or on a Linux operating system. So the very first thing we're going to do here is cover comments. This is a comment. Just like many other languages, you can create a comment just by putting 2 dashes and then whatever you want. And if you want a multi-line comment, you can just type in multi-line and then close that off. So there is commenting in C++. First thing we're going to do here is include some outside libraries. We're going to have some functions that we're going to want to use. So this one's going to allow us to use a function called cout and a whole bunch of other different things you're going to see here in a second. That'll be used for vectors, this will be used for strings, and then this will be used for file I/O. Now all of your code is going to be contained inside of a main function like this, and then you're going to have a curly bracket, and then you have a closing curly bracket. Now inside of here you could call the function cout either using cout or std cout like this. What I want to do is get rid of this part, and how I get rid of that is right here, right after the include statements. I'm going to type in using namespace st, and that's going to keep me from having to type that out every single time. Now if you wanted to do a basic hello world type of statement here, all we're going to have to do is type in hello world using cout, which outputs the text that we have here, and a carriage return whenever we type in the same brackets you see right there, and end L. That's for the carriage return, and this right here is saying we want to output this on our screen. The other thing we need to do here is call return 0. You're always going to do this, and 0 stands for the execution went through perfectly fine. So just to keep everything simple. Jump over here in the terminal, and this is the command I'm going to use to run this. It's called ctut, and make sure with your C++ programs you always end them with CPP as the extension. And then right here I'm saying that I want to use the version 11 of C++. Then I'm going to compile that, and then to run it I'm going to put /a.out. And if you're on Windows, you would just type in A, and you can see hello world prints out right like that. So the next thing we want to discuss here are variables and data types. Now variables start with a letter and can contain, of course, additional letters, numbers, or underscores, but they must start off with a letter. And here we're going to actually create a constant variable, which is going to be of type, data type, doubled, which means that it contains floating point numbers or decimal places. And here we're going to give it the value of 3.1415926.535. And once again, constant being here just means that this value cannot be changed, and normally whenever you define constant variables you make their names in all uppercases. Other data types that are available to you are characters, which contain just one character, and they are going to be surrounded by single quotes. So let's say I have a grade equal to and A, right like that, and there you go. And a character very specifically is going to take up 1 byte inside of memory. Booleans, which normally start with is whenever you're defining the variable name, can contain true, which is going to be comparable to 1, or false, which is going to be comparable to 0. Ints or integers are just whole numbers without decimal places. Floats are floating point numbers just like doubles, and they normally are accurate up to 6 decimal places. Let's just say favorite number and just copy this guy. And doubles, of course, like I said before, are also floating point numbers, but they tend to be accurate up to around 15 digits in length. And then of course if I want to output one of these variables on the screen, I'm going to use cout again, and then I could say favorite number inside of double quotes, and then to output it I just put another bracket inside of there, fav num, and then of course end L for a carriage return, and there you can see favorite number 3.14159. Now, of course, there are other data types that are available. We have short ints, which are going to be at least 16 bits in size, long ints, which are going to be at least 32 bits, long ints that are going to be at least 64, unsigned ints, which are going to be the same size as the signed version, and long doubles, which are not less in size than regular old doubles.
3. Java is a general-purpose programming language that is class-based, object-oriented, and designed to have as few implementation dependencies as possible. It is intended to let application developers write once, Run anywhere or meaning that compiled Java code can run on all platforms that support Java without the need for recompilation. Java applications are typically compiled to bytecode that can run on any Java Virtual Machine (JVM), regardless of the underlying computer architecture.
The basic parts of a Java program. So looking at the screen, you can see at the very top there are 2 forward slashes, and this indicates a comment in a Java program. It's ignored by the compiler. You can have comments on their own line or at the end of a Java statement, like we see where it says class header, method header, Java statement, and those are just comments. So you can basically write those as notes to yourself to describe your own code, or they can be used in many other different ways, and I have a separate video on what comments are and the different types of comments. There's also at the very top of your program, you should have a line of code that looks like this: public class hello world, or the name of whatever your class is called. And this is called the class header. It contains the keywords public, class, and then the name of your class should start with an uppercase letter, and every other second and third word and so on should also start with an uppercase letter. This is called camel case. And the name of this class should match the name of your .java file. This hello world class should belong in a hello world.java file. Then right underneath it is a curly brace, and then a closing curly brace that's lined up right directly below it. And this is the body of the hello world class. And within the body of the hello world class, there is what's called a main method, public static void main, string square bracket args. And I don't expect anybody at this point to know what any of these words mean, but I'll have a separate video later that describes every word in the main method header. Just understand that for now that the main method header is needed for any executable Java program. If you want your program to be able to run, it has to have this main method in there. And let's say, for example, you wrote a Java program with 1,000,000 lines of code. And where is the first statement that's going to be executed? It's going to be the very first statement inside the main method. Your program lives and ends in the main method. It starts from the opening curly brace to the closing curly brace. And the code inside the main method may call other code outside of the main method and inside other methods, for example, or create objects of other classes. But for now, just understand that your entire program lives and ends in the main method. You need one main method for every executable Java program. In this example, there's just one statement inside the main method that says system.out.println, which basically translates to whatever's inside these parentheses printed out to the screen. And it prints out hello world, which is a string literal. And the statement ends in a semicolon, like all other Java statements should do. But notice that there are no other semicolons anywhere in this program. The class headers, the method headers, the curly braces, none of these things have semicolons at the end because they're not Java statements, they're framework type code that shouldn't have semicolons.
4. Delphi is a programming language and an integrated development environment IDE for rapid application development of desktop, mobile, web, and console software. Currently developed and maintained by Embarcadero Technologies, which uses an event-driven paradigm. The language is also called Object Pascal. Delphi's compilers generate native code for Microsoft Windows, macOS, iOS, Android and Linux x64 only.
The Delphi IDE. We learned that Delphi provides us with many different pre-developed components like buttons, edits, labels and so on. We also saw that all these components are organized in tabs in the component palette. Furthermore, you learned that the form called Form 1 is placed on the IDE by default when you create a new application or when you open Delphi for the first time. I also explained that the form is the primary component on which all other components that you need for your application are placed. In this topic, we will look at forms. All Windows-based graphical user interfaces consist of at least one form. This is the window that your users normally see when your application is running. This window has a title or caption that displays the name or description of the form. For example, the first form that is added to the IDE is named Form 1 by default. The title or caption of a form will also display the name of the form, in other words, Form 1. Later you will learn that it is a good practice to change the default names of components to make them more descriptive and easier to identify. You can change the form's name and caption property in the Properties tab of the Object Inspector. Before you do that, always make sure that the component that you want to change is selected by clicking on it in the IDE. This is important because sometimes you have many components on your form, and if you do not select the component that you want to change first, you may change properties for the wrong component. At the moment, I only have a form in my IDE, but I will select it in any case by clicking on it. I know that the form is selected because its name is highlighted in the object preview. I can also see that the form is the selected component because its name is displayed on the top of the Object Inspector. Now I know that any properties that I change in the Properties tab of the Object Inspector applies to Form 1. Let's go ahead and change the caption property to First Demonstration. While I'm typing the new caption, I want you to look at the form's title and see how it also changes. Now let's change the name of the form. You will learn later how to assign proper names to your components, but for now I will just go ahead and change the form's name to FRM First Demo without spaces. I'll explain that later, but what I want you to see, by changing the name of the form, I'm not changing the caption. The caption is the title that the user will see when using the form. The name is the programmatic identifier that you will use in the IDE and in your code to identify this form. You will now also see that the name change reflects in the object preview and in the Object Inspector. The form has many other properties that you can change. Let's look at the color property. Make sure that the form is the selected component and scroll to the color property. Notice that the name of the color property is spelled COLOR. That is the American spelling of color. When you click on the color property, you will see a drop-down button on the right-hand side of the cell next to the property's name. Click on that button and a color palette will drop down. Here you can select a color for your form. Notice that colors in Delphi have a CL prefix. Let's select lime and see how the background color of the form changes to lime green. To change the size of the form, you can set the height and width properties of the form. Again, make it a habit to check that the component that you want to change is the selected component. Here I can see Form 1 is selected in the Object Inspector. To change the height of the form, I scroll to the height property and click on it. At the moment, the form's height is 640. Let's change it to 800 and press the Enter key. And there you can see now I changed the height of the form. To change the width of the form, I must scroll down further to find the width property. Now remember, the names of the properties are listed in alphabetical order to make it easier to navigate. Therefore, width will be way down in the Object Inspector. I click on the width property to select it. At the moment, the width is 870, but I want to change it to 400. I type 400 and press Enter to persist the value. There you can now see how the width of the form changed. Another way to change the width is to drag the left border of the form to the left or right. See how this action also changes the width property as I'm doing the resizing. You can also do the same with the height property by dragging the bottom edge up or down. Again, see how the height property changes as I'm doing the dragging. I can also place my mouse pointer on the bottom right corner of the form and change the width and height properties simultaneously. Both the width and height properties change in the Object Inspector as I'm dragging to adjust the dimensions of the form. As you can see in the Object Inspector, a form has many other properties that you can change. The best way to learn these properties is to explore them yourself. Be creative and experiment with different properties.
To summarize our lesson for this session, non-procedural languages are considered object-oriented programming. It is different from a procedural language since statements as a whole, when executed line per line. Instead, a series of instructions are executed as a whole when an event occurs. They are event-driven. Examples of events are click, double-click, drag and drop, and mouse click. Object-oriented is a programming style which is associated with the concept of class and object and various concepts like inheritance, polymorphism, abstractions, encapsulation. Examples of object-oriented programming languages. Number 1, Visual Basic is a third-generation programming languages which is event-driven. It is developed by Microsoft. It is intended to be user-friendly and easy to use. Number 2, C++ is an object-oriented computer language. It introduces object-oriented programming principles, including the use of defined classes. Number 3, Java is a general-purpose programming language that is class-based, object-oriented. It is intended to let application developers write once, run anywhere. Number 4, Delphi is an integrated development environment for rapid application. Delphi's compilers generate native code for Microsoft Windows, Mac OS, iOS, Android, and Linux.
Do the activity. Definition. Define the non-procedural programming languages listed below. Write your answer in a clean short bond paper with your name, grade level / section and the date today. 1. Visual Basic. 2. Java. 3. C++. 4. Delphi. 5. OOP. Identification. Identify the following statements. Write your answer on the space provided before each number. 1. It refers to binding properties with functions. 2. It means hiding details from the outside world. 3. It is an instance of a class which has physical existence. 4. It is the design or blueprint of any entity, which defines the core properties or functions. 5. It means many forms. For your assignment. 1. What is a flowchart? 2. What are the most common symbols used in flowchart?
I hope you guys learned a lot from our lesson for this session. See you on our next computer class.